Hi everyone. So usually I record my videos and try to make it as seamless as possible and edit them and try to make them as short as possible. But there is an Orga 1 exam today, and everyone who I know who's taking Orga 1 is struggling with Fisher projections. So this video might be a little bit more messy. I haven't really decided exactly what I'm going to say or how I'm going to explain it, so bear with me. So I'm going to be showing you guys how I understand Fisher projections. I suck at visualizing these guys in space. But what's happening is these guys off to the sides are going to be on wedges, and then the up and down are on dashes. This is what it looks like. When you are doing stereochemistry with something on a wedge, when your smallest group, when your hydrogen is on a wedge, and you do your little stereochemistry and you find out it's an R, when your lowest priority group is on a wedge, you need to flip it. It's not an R anymore. It's an S. So in this case, I want you to notice that both of my lowest priority groups, which are hydrogens, are on wedges. So whatever you calculate your stereochemistry to be, it's going to be the opposite. I suck at visualizing this, and a lot of people are like, well, when you look at this carbon and then you look at it from underneath and then you see that it's on the left versus the right, I can't handle that. I can't do it. I use stereochemistry. That's why I explained it. So first things first, when I do this, I want to count my carbons. Now, if you are also asked to name it, this is not, when you count your carbons on your Fisher projection, that's not the carbon count that you're going to use to name it. It's just the carbon count that you're going to use to help you put it into your bond line structure. So we have 1, 2, 3, 4. We have 4 carbons. So this is a butane. 1, 2, 3, 4. Now, this is where it gets a little bit tricky. This is not this, okay? What this is we are looking at it like, it's hard to explain. I'll show you. But let's say I had something on a wedge here and my hydrogen was dashed. Let's say I had a CH3 here. And let's say I had a CH3 here and my hydrogen was dashed. That's not what we're looking at. You have to rotate it. And this is what we are looking at. With our Fisher projection, we are looking at the carbon backbone. So let's say I'm standing right here and I'm looking at it like this. These guys, so we said that they are on dashes. These guys are on dashes. Do you see how they're going away from me? So that means if this was on a wedge here and I flipped this guy, he's no longer like this. He's now like this. I flipped him up. This is now swapped. So this guy is now that. Do you see how this will kind of correlate to this? Because that's what a Fisher projection looks like in a bond line. But if you want it like this, you'd have to flip whatever one was going down. I don't know how else to say it. It's hard to explain with, just words. So let me show you in an example. I'm going to do both. So 1, 2, 3, 4. And I'll show you with stereochemistry. So this is going to be my first one. I have 4 different groups attached to this carbon. Now let's rank priority. Attached to this carbon, I have an oxygen, a carbon, and a hydrogen. This guy is automatically first priority, okay? Next priority, when we look at this carbon, so this is now our tiebreaker. This carbon is attached to 3 hydrogens, whereas this carbon is attached to 1 hydrogen and a bromine and another carbon. Who wins? This guy wins. This entire group is priority 2. This is priority 3, and then of course this is 4. Let's do our little stereochemistry, 1, 2, 3, like that. That is S. This is S. But what did I tell you? Our hydrogen is on a wedge. So is this really S? No, it's R. When we numbered our carbons, this was carbon 1, this is carbon 2. So in both of these, I'm going to go to carbon 2, and I'm going to set this up. Coming off of carbon 2, I have an oxygen, I have an OH group, and I have a hydrogen. So I'm going to just put the OH group here for now, just because I don't typically draw the hydrogens. I mean, you can. But now I want to figure out whether this oxygen is going to be on a dash or a wedge. And I'm going to just do this with trial and error, or just like you practice it. I don't visualize it. I need to like see what it is. And I'll show you how to visualize it, but like, we'll see. Okay. This is a lot easier to see. This is priority 1. And then I'm going to have a bromine here because this is carbon 3 on my thingy, and carbon 3 is right here. This is obviously priority 2. This is priority 3. Now let's do 1, 2, 3. This is R. R on its own. So I did not want it to be flipped. I do not want to flip it. So is my hydrogen going to be on a wedge or a dash? It's going to be on a dash. I don't want it on a wedge, because if my hydrogen was on a wedge, this would have to be S. So my hydrogen is actually, my hydrogen is on a dash, which means what? It means that my OH is going to be on the wedge. Do we see that? Yeah, we got that. Okay. So I calculated this was R. This is R. So my OH is on my wedge. Why? Because it's R, and that means I want my hydrogen on my dash. Makes a lot of sense, right? Now, when I have it in like the bond line that corresponds to this guy, you can see that my bromine is on the same side as my oxygen. So if you were to do it like this, you would know, here, wait, let me do this in a different color. I'm going to be using red now. This bromine, do you see how it's on the same side as the oxygen? So when we're looking like this and our oxygen is on a wedge, our bromine here is also going to be on a wedge. What happens when I flip this down and I do this instead? My bromine is going to be on a dash. That's what happened there. This is not the most, especially when you get into having more stereocenters, it's a lot harder to figure out. So I'm going to show you a stereochemistry again. Or you could just know that because it goes opposite here and it looks like they're on the same side, you'd have to put the bromine on a dash. Okay, hold on. So let me just say that one more time. You could recognize, once you find out the stereochemistry of this and it looks good, because the next carbon is opposite, but we look at our Fischer, when they're on the same side, they will both be wedges. So if now it's opposite, it now has to be on a dash, not on a wedge. Because if you were to draw it like this, it'd be on a wedge. If you were to draw the actual bond line, it'd be on a dash. But let's use stereochemistry to show the exact same thing. I'm going to do this in light blue. This is my priority 1. This is my priority 2. This is my priority 3. And then this is 4. 1, 2, 3, 4. That is R. But is it R? No. Why? My hydrogen is on a dash, or my hydrogen's on a wedge. This is S. So I want my stereochemistry to be S. So now let's find the stereochemistry right here. Priority 1, priority 2, priority 3. That's S. Perfect. I don't want to change it. Bromine stays on a wedge. All right, using that logic, we are going to do this to this. I'm going to start by just counting the carbons. And again, if you are also asked to name this, the carbons that I am numbering do not correspond to the name of them. It could be a totally different one. I could have numbered it like this: 1, 2, 3, 4, 5, 6. And if I were to name it like this numbering would be wrong, because I would have wanted this guy, my OH on this guy, to be like the lowest. I'm getting like way too ahead of myself here, but first thing you need to do is count your carbons. 1, 2, 3, 4, and then you could have just called this 5 or just like, or 1, 2, 3, 4, and then known that off carbon 1 you have a methyl. And then on carbon 3, you need an ethyl. So you're adding 2 more carbons. That's a lot of work. Just try to find your longest carbon chain and include the whole shebang in there, okay? 1, 2, 3, 4, 5, and 6. So that's what I drew here. 1, 2, 3, 4, 5, 6. I'm going to start with carbon 2. So this is carbon 2 right here. Carbon 2. This is carbon 3. This is carbon 4. What I'm going to actually start by doing is drawing the substituents off of it. On carbon 2, I have an OH coming off of it and an H, but I'm not drawing the H's. I have an OH. I have an OH. So I'm going to just draw them with a straight line for right now, just so we know that they're there. This is an OH. 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 Okay. Now the question is it like this or is it like this? You know what I'm saying? Okay. Well, moving on. I always start by finding the stereochemistry. So for this one, we're going to start here. Let's start by ranking priorities. We have a carbon here. It is attached to a C, an O, another C, and an H. Tiebreakers first. This guy wins first priority. This guy wins fourth priority. Now we're down to my CH3. So my carbon is attached to 3 other hydrogens, or my carbon is directly attached to an oxygen. Who wins? This entire group becomes priority 2. So I'm going to actually take these off just so that, okay. We said that this was priority 1, this was priority 2, this is priority 3, and then this was priority 4. I'm going to do my little 1, 2, 3. So I started from 1, I went to 2, then I went from 2 to 3. Okay, this is R. Now my question to you is, what happens when my hydrogen, my lowest priority group, is on a wedge? You need to flip it. Duh. Hello. Okay, sorry. This is actually S. So I need my carbon 2 to have S stereochemistry. Okay, now let's move to the bond line. Let's label priorities here. This is priority 1, this is priority 2, and this is priority 3. We have 1 to 2 to 3. This is R. Uh-oh, I don't want it to be R. I want it to be S. So I need this to be flipped. How do you get it to flip your stereochemistry? When your hydrogen is on a wedge. So what does this mean my oxygen is going to be? Dashed. That's my answer right there. Boom. Now I'm going to show you how to figure out the rest like intuitively, okay? We already know that if I were to draw it like this guy, if I were to make it like, instead of that, I were to like, and it'd be like this, like, if you were to continue it, this is how I would draw the outline for this. This is my carbon 1, 2, 3, 4, 5. This is what it would look like in the straight line, not the bond line. The bond line has the rotations, but if I wanted to do the exact thing here, this is what it would look like. Do you see how it's like a C shape? It's like, that's what, okay, moving on. We already started off by saying that I need this to be S. Okay. This is carbon 2. Carbon 3, my OHs are on opposite sides. So here is my OH also going to be on a dash? No, it is going to be on a wedge. Okay. Put it on a wedge. Here, we see that my OHs are on the same side. So that means my OH here is going to be also on a dash. Why? Because it's opposite of this guy, but it's the same as this guy, which we know is on a dash. this is what it would look like. This is so simple when we do it like this. So I think that it's really easy to find the stereochemistry of the first one and then look at your second one. If my second one was right next door, so if it was this would need to be on a wedge, but this is flipped upside down. What happens when you flip a wedge upside down? It's now a dash. Does that make sense? So you don't have to draw all of this. You can think, okay, ready? This is on my wedge. I see that these guys are on opposite sides. So if I were going right next door to it, it would be on a wedge. Sorry, I think I just switched up saying wedge and dash. You know what I mean, okay? They're on opposite sides, but I know that this needs to be rotated. So when it's upside down, it's also on a dash. So you can draw this if it makes you feel more comfortable, or you could just intuitively know that it's like, you can say it out loud in your head, whatever. Then you have this guy. Okay, they're opposite. Or you can think these guys are on the same side. If they were in line with each other and this was a wedge, they would have been opposite. But these guys are on the same side. They're also on the correct way. He is also on a wedge. Now, if you want to go through and figure out each specific spot with stereochemistry, you totally can, and it will work out. Okay. Is it that deep right now? No, you don't need to do that. You just need to start with one. And then when you go to your next dot or your next carbon, you need to know that it's actually the opposite of this. So if this guy was on a wedge, your next carbon underneath it or down below it, you need to flip it. So this is also, oh, I kept saying it's on a wedge. It's not on a wedge, guys. It's on a dash. But you see what I'm saying, like whatever. Okay, I hope this makes sense. Okay, I hope this helped at least a little bit. Good luck with your exams later today. Let me know if this helped. Definitely subscribe to my channel. Leave a comment what other things and topics you want to see next. And if you go to my YouTube, if you go to my Instagram, Chemistry with Ricky, in the link in bio, I now have a like little sign up link for tutoring sessions. It tells you my availability and you can just click and make an appointment with me then and there. And in like after you select a time, I ask like what course you're in. So if you're in Intro to Chem, Chem 1, Chem 2, Orgo, and then I ask what you want to review. So also go give my Instagram a follow. Hello, like why else are you here? Subscribe to my YouTube channel. Let me know what you want to see next. And if you do want to book a tutoring session, go to the link in my Instagram bio. Okay, good luck, everyone.